Okay, 9.3, we are going to continue solve using square root, but we're going to solve a little bit harder equations. We're going to solve something like this. But before we do that, I'm going to review what we did last section, which is solving equations like this, where the single variable is squared using square root. You don't need to copy this if you understood the notes from last time. Okay, so for this, it says x squared equals 25. Because the x squared is isolated, to cancel the squared, I can square root it. If I square root the left, I square root the right. X equals, now the square root of 25 is 5, but because it was x squared, I know the answer can be positive or negative 5. And then this is the short way to write that. Okay, I'm going to go ahead and look at B. B says n to the second equals 21, so the n squared is already isolated for me, so I could square root both sides. N equals, I'm going to get a positive and negative answer. Now the square root of 21 is, it's irrational. Can I simplify it? Well, I could do 3 times 7, but 3 and 7 are, square root of 3 and square root of 7 are also irrational. So I'm going to leave it as positive and negative square root of 21. And you could list that out as well as positive square root 21, negative square root 21. Just make sure the negative is in front of the radical. Okay, and then let's look at this last one. It already says e to the second equals 24. So to cancel the squared, I square root it. That brings me down to e. I will get two answers, a positive and a negative. Now square root of 24 is irrational. Can I simplify it? I can't, because 24 is 4 times 6, and the square root of 4 is 2. The square root of 6 is not 3, so leave it square root 6. So my e can be positive or negative 2 square root 6, and that should be in simplified form whenever possible. Okay, now let's look at some more complicated equations to solve. Okay, I'm still going to solve using square root, and I'm going to simplify my answer where appropriate. Okay, now the weird thing about this is the squared is outside the parentheses. So I kind of want to plus the 1 to the other side, but I can't because the minus 1 is trapped inside the parentheses. So to untrap it, I need to cancel this squared first. To cancel this squared, I'm still going to square root it. If I do it to the left, I do it to the right. Okay, now I'm going to bring down what I have left. The squared and the square root canceled. So now I have x minus 1 equals the square root of 25. It could be a positive or a negative answer. So I could get positive or negative 5. But I didn't solve it yet. I still need to solve it. So let me think about this. This is saying x minus 1 could equal positive 5 and x minus 1 could equal negative 5. So I'm going to split this into two equations and solve it both. You could solve it the way it is, and I'll show you on the next one. So I wrote x minus 1 equals positive 5 here, x minus 1 equals negative 5 over here. Then I'm going to go ahead and solve both of these equations. So I can plus 1. So x equals 6 is one of my answers. And if I think about it, if I plug 6 in here, 6 minus 1 is 5. 5 to the second is 25. So that answer makes sense. Let me plus 1 over here. So I get x equals negative 5 plus 1 is negative 4 for my second answer. Let me think, does that work? If I did negative 4 minus 1, I would get negative 5. Negative 5 to the second power is also positive 25. So both of those answers work. And because it was quadratic, most of the time I get two answers. Okay, let's look at B. B says the quantity n plus 7 squared equals 4. Let's see. Now, the n plus 7 is trapped together in the parentheses with this squared on the outside. So to cancel the squared, I'm going to square root both sides. The squared and the square root cancel, so I get n plus 7 equals. Now the square root of 4 is 2. But because it was quadratic, I'm going to get a positive and a negative 2. Now, I could split this up. I could say n plus 7 equals positive 2 and n plus 7 equals negative 2. And I think that's still a good way to solve it. But I know some of you are going to try to do the shortcut, so I'm going to show you the shortcut officially. Okay, so if I want to solve this, n plus 7 equals positive and negative 2. To cancel the plus 7, I would minus 7. Okay, is this allowed? It is allowed, but you have to be very, very careful. Okay, now what is this saying? It's saying plus or minus 2 minus 7. So there's two situations. If I do positive 2 minus 7, I get -5 for one of my answers. If I do -2 minus 7, I get -9 for my other answer. Okay, so it still works, but in your head, you have to think about what it's going to turn out to be. If that confuses your brain, as it probably should, I could also write n plus 7 equals 2, n plus 7 equals -2, and then solve both of these separately. And I still get n equals -5, and -2 and -7, I add them up, and I still get n equals -9. So whichever way is more reliable for you is the way you're going to want to do it. Okay, let's look at some other ones. Okay, let's look at C. C says the quantity 3p minus 5 squared equals 16. Let's see, the 3p minus 5 is stuck inside the parentheses, so I can't cancel them out until I get rid of the squared. So I am going to square root both sides. 3p minus 5 equals, the square root of 16 is 4, but because it was quadratic, I'm going to do plus and minus 4. Now, if you want to try to solve it like this, you can, but with the 3p there, it's going to make it pretty tough. So I'm going to split it into 3p minus 5 equals positive 4, and 3p minus 5 equals -4, and I'm going to solve it both ways. But if you want to try to solve the original equation as is, go ahead. I'm going with be careful. Oh, I still need to divide by 3. So p equals 3 is one of my answers, but it's not my only answer because it's quadratic. I'm expecting to get 2 answers most of the time. -4 plus 5 is 1. Divide by 3. P equals 1/3. So I got P equals 3 and P equals 1/3 is my 2 answers. Okay, now we're going to look at D. D is going to have an irrational root. But the way I start, it's the same. So it's f plus 5 squared. Because the f plus 5 is in parentheses, I need to cancel the squared before I cancel anything inside the parentheses. Okay, so this is going to give me f plus 5 equals, now what's the square root of 11? It's irrational. Can I simplify it? No, because it's only 11 times 1. But I still need a positive and a negative square root of 11. Okay, now I could split it into 2 or I can solve it the way it is. I'm going to show you both ways so you can decide. So positive square root of 11, f plus 5 equals negative square root of 11. Okay, I'm going to minus the 5 even though this looks weird. Okay, now here's the problem. Those are not like terms. This has a radical, this does not have a radical. So rational, irrational. So the way we write our answer is we put the rational part first, which is the -5. And then I put the square root of 11 second, but these are being subtracted or added. So this is a positive square root of 11. So I write plus square root of 11. And even though that looks weird, that's my answer. I'm going to go ahead and do the same for this one. Okay, and again, I know it looks weird, but I put the rational part first, which is the -5, and then the minus square root 11 goes second. And then that's my final simplified answer. That's the best it can look. Okay, now if you want to solve this all at once, and actually with the irrational ones, sometimes it's easier to solve it all at once. Okay, I would still minus the 5. Okay, now I put the rational part first, which is the -5. And then because I put the irrational part first, I put plus minus square root 11. Okay, and if you look at this answer, this is the same as this and this because -5 plus square root 11 matches this answer. -5 minus square root 11 matches this answer. So whichever way is better for you is the way you're going to do it. Okay, let's do 2 more because the irrational part is a little strange. Okay, but the method of solving will be the same, so I'm going to cancel the squared. E minus 6 equals the square root of 10 is irrational. Can I simplify it? Square root of 5, square root of 2. No, I don't know the square root of 5 or square root of 2. So I'm going to leave it square root of 10, but I'm going to get a positive and a negative answer. Okay, now I'm going to solve it the way it is because it's irrational. And so splitting it up doesn't make it that much easier. It might make it harder. So since it's e minus 6, I'm going to do plus 6 on both sides. Okay, when I write my answer, I put the rational part first. So this positive 6, I put first. The irrational part goes second, and it's both a positive and a negative square root 10 that I am adding. So this is my final answer, even though it looks weird. Okay, last one. M minus 4, the quantity squared equals 99. Again, the m minus 4 is stuck in the parentheses, so I cannot cancel anything in there until I cancel the squared. M minus 4 equals, what's the square root of 99? It is irrational. Can I simplify it? Yes, because I could do 9 times 11. Square root of 9 is 3. Square root of 11, I don't know. So then I'm going to get positive and negative 3 square root of 11. And if it will simplify, you should. So just at each time, think about it before you write your answer. Okay, now if it's m minus 4, to cancel the minus 4, I will plus 4. The 4's cancel. I get m equals positive 4. And then what do I have? I have plus or minus 3 squared 11. Okay, and I cannot add those together. I know the 4 plus 3 is very enticing, but this 3 is stuck to the square root of 11. So for this to be a like term, it would also have to have a square root of 11. So they're not like terms, so I'm going to leave them separated. And then that's my final simplified answer.